All right, as we get going now in our physics unit, our first physics unit, one-dimensional motion, so moving back and forth in one dimension, meaning that it's either forwards or backwards. We're not going left and right, and we're not curving, just forwards and backwards right now. I need to remind you of some basic definitions that you learned in middle school. Let's start out with scalars and vectors. Now, a scalar is just a measurement. So, for example, 3 meters would be a scalar, or 37 meters per second, that's actually pretty fast. 37 meters per second would just be a scalar. It's just a measurement. Other things that are always scalars, you'll see differences coming up. Temperatures, 22 degrees Celsius is a scalar. It's just a measurement. On the other hand, a vector is a measurement with a direction. It has a very specific, and only one, very specific direction with it. So, for example, let's go back to our distance, 3 meters. Let's make it displacement, 3 meters north. If I say 3 meters north, now I have the magnitude, this is called, aka the measurement, called the magnitude, and I have a direction, north. I could also do this with angles, right? 3 meters at 32 degrees, right? So with an angle, now I'm giving it a direction. One that throws people off, especially in one-dimensional motion, you can also indicate a direction by using the positive and negative sign. Because if I put a definite positive 3 meters in front, that's saying go 3 meters forward, or 3 meters in the positive direction. So that positive sign actually acts as a direction, or negative 3 meters. That negative sign acts as a direction. Now, up here with scalars, yes, there is an implied positive there mathematically, but since it's not specifically listed, it's just a measurement, it's just a magnitude. It's not a measurement with a direction, thus it's not a vector. If you put it in, now it becomes a measurement with a direction. And this can be done here where you give almost any measurement a direction. So it can become a vector in almost any way, shape, or form. We're going to deal with mostly vast majority vectors, with some notable exceptions. Some measurements have no choice. They are only magnitudes, like temperature. Distance. Distance is how far you go. Each step counts. It is a scalar. Base units for distance is meters. On the other hand, its counterpart, if you will, vector counterpart, is displacement. That's the distance traveled in a specific direction, specifically from the start to the end. To figure out what your displacement is, you subtract your final position, your end, from your initial position, and you get your displacement. It has a definite direction from start to end. It's a vector. It has a base unit of meters. So if you think about the difference between them, distance is the actual route you go. Every step counts, and what direction you went doesn't matter. So if this is a cross-country course and you went along the blue line here, right, and went from the start all the way over there to the end, that's the distance. It's just a number, however many meters you went. Displacement, though, think about that term, break it down, the linguistics of it. The displacement, placement, so how far I am displaced from my original position. So it runs from the start to the end, straight line, arrow, the distance from start to end with a definite direction from start to end. It's a vector, how far you go in a very specific direction. A few more definitions here for you. Speed. Speed is a scalar. I think that's pretty self-explanatory. You've been using this in your everyday life for a good while now. It's how fast you're going, but it's a scalar. It's just a number. It has units of meters per second. Now, speed is a distance divided by a time, or the rate of change of position. And you need to go ahead and start thinking of rate of change. How fast you go really isn't a good way to describe it. Rate of change of position is a much better idea. How quickly you are changing your position, aka how fast you're going. Equation, speed equals distance, how far you went, divided by time. Notice scalar divided by scalar gives me a scalar of speed. Now, velocity is its sister or brother to speed. Velocity is speed, but it has a specific direction. Thus, it is a vector. Units are the same. meters per second. And you'll see this, by the way, and I should have, I did have it up here too. Whenever you have it to the -1, that just means it was in the denominator. For example, 1/3 is the same thing as 3 to the -1st power. This 3 down here in the denominator is to the +1, and if you bring it up into the numerator, then it becomes a -1. So basically, don't get freaked out by that. That's not a big deal. If you see meters, seconds, -1, that's the same thing as meters divided by seconds. Equation for it, velocity equals, this S stands for displacement. Okay, S in an equation stands for displacement, T stands for time. We're going to come back to that equation. Now, there are 3 other types of velocity you need to be aware of: constant velocity, average velocity, and instantaneous velocity. Constant velocity is a velocity that does not change. Now, that's pretty self-explanatory here. If you're thinking about it in a car, if you're going in the same direction, the road isn't turning. That's critical, because if the road turns, you're not going at constant velocity. You might be going at constant speed, but if the road turns, you have a change in direction. Thus, you're not going at constant velocity. But let's assume the road is going straight, you're not turning at all, and you turn on cruise control. The purpose of cruise control is to keep you going at a constant velocity. If you look up here at this velocity time graph, you can see here during this portion of it, the velocity, because that's what's on my y-axis, the velocity is remaining constant. Average velocity is the total displacement, how far you went total, divided by total time. So in our velocity graph up here, we are constantly changing our velocity. The average velocity of it would say, okay, figure out how far you went total. Doesn't matter that sometimes you were going 25 meters per second, sometimes you were going 20 meters per second. How far did you go total, and how long did it take? Time. Divide by this equation right here. So this is technically the constant velocity equation, but it's also used for average velocity. Divide, and you figure out your average velocity. Instantaneous velocity is the velocity at an exact moment. So in other words, if you have a velocity time graph, you look at that graph. Let's say I want to figure out the velocity at this time. I trace it up, and then I come over. Whatever velocity the object is at that exact moment. This is given in a car by a speedometer. Now, the reason it's called a speedometer is because it's only showing you the speed. It's not showing you speed with a direction. It only shows the speed part. But if you're not changing your direction at all, it's how fast you're going at that exact moment. It can be your velocity. Technically, if we were going to have a velocimeter, we would need to have the speed and a direction with it. Kind of odd sounding, isn't it? Acceleration, rate of change of velocity, aka how quickly you are speeding up, slowing down, or turning. Now, let me say that again and make sure that you actually get that written down. If you speed up, or if you slow down, or if you turn, you are accelerating. Now, lots of times we call speeding up accelerating. Slowing down, we would call decelerating. Decelerating is the same thing as negatively accelerating. We'll talk about that in the next video. Turning, though, is acceleration also, because velocity is a vector. It has a very specific direction. So if you change your direction, you have changed your velocity. And the only way you are going to change your velocity is by accelerating. So whenever you change your velocity, you have accelerated. Acceleration, rate of change of velocity. Units, meters per second squared, or ms -2 meters seconds to the -2nd power. An equation, acceleration equals final velocity minus initial velocity. I know it seems weird, it's u, but change in velocity here, rate of change of velocity, final minus initial, divided by time. That's your equation for acceleration. All right, so there's your reminders about things that you should have already learned in middle school. Now we're ready to start heading into lesson 2 so that we can really dig into the beginning parts of physics.